Factorizing quadratic expressions is a subtopic we are going to see. Okay, what happens if we are factorizing quadratic expression? Now, the term quadratic means the expression we are having, it has the highest power as 2 in one of the terms. Okay, a quadratic expression is in a form of ax squared plus bx plus c. With b, the sum, and sc, the product. When we get a times c, that's how we get the product of the factors. It's easier to factorize them if they have even number of terms. Even number of terms means like 2, 4, 6, and 4, and of course there are any natural, you can't have 6. Okay, to make x squared have even terms, we bring in factors whose sum is b. The sum is b, and their product is sc. To get the product of those, you have to get a times b. Let us see some examples here. All you do, you first check, look at this and this, it's even. So now they are even. This is one term, this is the second term, so they are even. So you can easily factorize this one. So that x is common and x is common. So from there, if you have factorized this, you see this will be now, you remove x. When you remove x, divide here by x, you get x. When you divide here by x, you get 3. I say past that. So you have factorized that. Now with these ones, with the 2, they are very easy to factorize. Either you use this method or you use the difference of the square, which we shall see there later. Now, what happens now if I have this one? So that this one has 4 terms. 1, 2, 3. There are 3 terms. So this one will say you get this, you introduce in factors whose sum is b. When you compare this expression, see that if I compare with a, x squared plus bx plus c. My a is 1, the coefficient of x squared. My c is 2, my b is 3. So the numbers I'm bringing in, they should be having their product as 1 times a times 2, which is 1 times 2. Their product should be 2, and then their sum should be 3. In simple terms, always those numbers are going to be factors of this number times this. Look at this. When you see this is 1 already, this is 2. Now you check the factors of 2. Factors of 2, you have 1 and you have 2 because it's a prime number. It has 2 factors only. So now, to mean that the numbers I'm going to bring, you check. Then when I multiply them, I get 2. What about when I add them? When I add them, I get a 3. So this is the right pair. It means that now, where there is the 3x, I'm going to do this. Look at this. X squared plus. Now that there is 2, I mean 3x. I said 2x plus x. So 2x plus x. Why? Because when I add 2x plus x, I'll be getting back my 3. Then plus my 2. This 2 here. Now, from there, what we do, you see x is common here, x is common here. When I remove x from here, I mean with x. When I remove x from here, I mean with 2. Now we start here, what is common is 1. Why? Always this bracket, we should put it also in the second pair of terms. Then so you start here, all I need is to remove a 1. When I remove 1, these values is, when you remove a 1, here will be made with x plus 2. Why? Because this bracket is already here. You see it's already here. So all you need to do here is remove a 1. So that this and this are common. When I remove x plus 2 here, I remain with this x. When I remove it here, I remain with a 1. And we have factorized that. When you expand this, you will get that. When we come to this now, you see the product is going to be 1 times 6, which is 6. Then their sum should be 5. Then you just look now. You look for the factors. If it, the moment you start this is the coefficient 1, you look for the factors of this number always here. So factors of 6 we can be having 1, we can have a 2, a 3, and then a 6. Which pair do you think when you multiply we get 6 and when we add those 2, we get a 5. You see, 1 and 1, when I multiply them, they don't give me a 6. So that is wrong. 2 times 2. Then I also have this and 6. So 1 times 6, I get 6. But when I add 1 plus 6, I don't get a 5. So that pair is also wrong. 2 times 2, I get a 6. When I add them, 2 plus 3, I get a 5. So this pair is okay. Now what you do, you use this pair and you break this into 2. Why? When you break this into 2, we shall be having even number of terms. These are only 1, 2, 3. Now when I break the 5 into 2 and 3, I'll be having now one more term, which will make them 4. Look at this. So that means 2, 5, I'm going to bring in 2 plus 3. So my y squared plus 2y plus 3y, then plus 6. You see, I've introduced 2 terms, but when I simplify this and this, I go back to this, so I've changed nothing. But I've created an even number of terms, which is going to make me factorize this with ease. So that when we add this and this, we get out our 5. So I'm not changing anything. I'm just dealing with the mathematics. So this y is common here and here. When I remove this y, I have y plus 2. Now what is common here? You see that this is the 3 is common. Orange, you need to break this term here. In simple terms, to bring y, you have to remove this 3 out. You'll be having y. What you do, you take now this 3, you divide it here. When you get 3, dividing this, you'll be having a 2. And so you have created this bracket here. Now this is common. When you remove it, here remaining with y, here remaining with 3. And that will be your answer. You have applied that. Now, this quadratic equation, the variable can change. It can change to m, to y, to x. So, this is just an example showing how they appear here. But it's not always x. Okay, so now I have m squared minus 2m minus 2. Coefficient 1. I look for the factors of this. These factors, when I multiply them, I get negative 8. When I add them, I get negative 2. You look for them. Now you have 8. You have 1, you have 2, you have 4, you have 8. You see that these factors now, when I add this, when I multiply these ones, I can't get 8. So I should multiply them to get 8. This and this, no. This and this, no. This and this, yes. So let us look at this pair here. When you multiply this and this, you get 8. When you add them, now, one of them should be negative. Why? If this one is negative, the factors, these 2 factors, the one which is bigger, you make it negative. If it's not the sum is negative. Now, the factor which is bigger, you make it negative. So it means that the pair I'm going to take is going to be 2, then negative 4. Why? Because I'm saying when I add here, I get a negative. So when you add these 2, we get negative 2, which is here. When you multiply 2 times negative 4, you get negative 8. So you have got the factors. Why? These are odd, you can't factorize them. Now you need to break 2 more, one more term and make them even. So now, where there is this, I'm going to substitute because when I add this and this, I get negative. So m squared now minus this one, I bring negative 4m. But because this wasn't there, I add negative 2, positive 2. When you start, when you get negative 4 plus 2, you get negative 2. So you have to take the last thing. So start m is common here and here. When I remove m, I have m. Here I'm with 4. What is common? So you want this to break it here so that you can factorize. What is not making this be m is a 2. You remove a 2. When I remove it there, here I have m. What you get this 2 divided here, will be having 4. This is common. When I remove this from here, I have m. When I remove this from here, I with a 2. And I factorize that is. We have now this. We have it's 1. So you get the factors of 12. So factors of 12, I have 1, I have 2, I have 3, I have 4, I have 6. Then I have a 12. Now, I need to when I multiply and get 12. Of course, the pair we can have 2 times 6, 3 times 3, also 1 times. Those are the ones which are given national. But their sum should be negative 4. When I take this, you saw that I won't be having 3 times 3, which is 12. But when I add them, it's going to give me a 4. So this pair is wrong. So I can't take this. When I get this 12, when I add them, it's 11. So it's also wrong. What about when I get 2 and 6? So start 2 times 6, I get 12. When I add them, I get, when I try subtract or add, I should get a 4. So now, this that we have a negative, so it means that the big one has to be negative. So I'm going to take now negative 6 and y, because this one, notice that this is negative. The bigger value of the 2 becomes negative. So now I substitute x squared, now minus 6x, then plus 2x minus 4. You just add x and add x here. So when I simplify this, I go back to this. And now I've carried even down is 1, 2, 3, 4. So they are even now. Factorize x. So that x, 2 is common here. And then move 2. Get here x. Divide this 2 here. You get negative 6. This is common. So you have x minus 6. X plus 2. And you die. Now I'm coming to this. This one now, the product is 15. This is 1. 1 times 15, you get 15. So the product is 15. So you come to 15. What are the factors? You have 1, you have 3, you have 5, you have also 15. So which pair? Now, you start the pair I'm going to take is this. When I multiply them, I get a positive. But when I add them, I get 8. Now it means that you should make them all have negatives. Why? So the pair I'm going to take is negative 3, negative 5. Why? Because when I add negative 3 and negative 3, I get negative 8. So this one is different from this. Here when you multiply this one, you get negative 12. But this one is that when you multiply them, you should get a positive. So I can't even, and this one, instead I can't, when I make one of them positive and one negative, they won't give me this. That's why now I'm making all of them negative. So this will be now p squared minus 3p. Attach a p here, the p here with their signs. Then minus 5p, then plus 15. What is common? P. When I move p here, I make 3. P here, p here. Now here, you want a p. But it means that this one, there is a p here, but you said it's negative, it has a negative coefficient. So you remove this negative 5 from p. You make with the p. Now you get this negative 5, divide it here. When I divide negative 5, I divide 15 with negative 5, I get negative 3. And negative by negative, positive. So that's how we do it. You get this side, divide it with this, you get a negative. 5 divided by 15 divided by 5, you get 3. When you multiply it back, you get this, and multiply it negative by negative, you get a positive. 5 times this, you get 15. So this is common. So p minus 3 into p minus 5. And we'll be through there. When we come to this, look at this now. We have now coefficients. So the product is 1 times 24, so you get to 24 quickly. So now I think we can see the values. So you have 1, you have 2, you have 3, you have 4, you have 6, you have 8, you have also 12. Which pair? I think we can see the pair I get, and when I multiply I get 24. When I add I get 5. Which pair? Where this thing we have a difference of 5. When you subtract this from this, you see that 3 and 8 is going to be the right pair. But now, when I add them, now it's that here the coefficient is positive and this one is negative. The moment that this is negative, it means they have different signs. Whenever I see that this is negative, they have different signs. The only way they can, whenever I look at this, whenever this is positive, they should be having the same signs. Whenever this is positive, same signs. Whenever it's negative, different signs. Whenever it's negative, different signs. Whenever it's positive, same signs. Whenever this is negative, now the signs should be different. Look at this now. So I have 8 and 3. So, because this is negative, the signs should be different. Which one should I attach? Of course, because this is positive, it means that the big one has to be positive. Then this now will be negative. Because this is positive, so the big one should be positive. Okay, so this will be now y squared plus 8y minus 3y. You attach y here, you attach y here, and bring them here. What is common is y. When I factorize out y there, I get y. 8, negative 3. You say I want to remove this negative from the y, so that I have this y. When you get this negative, divide it here. You get now negative 24 divided by what you have factorized out. We are now plus 8. With multiply this and this, you get back to the negative. So y plus 8 is common. You remove it here, remain with the y. Then you are writing the negative 3. And the number is done. Now, we are adding this as when the coefficient of the highest power is not 1. So the product is going to be 3 times 4, which is 12. So 3 times 4 gives me a 12. 3 times 4. So the A times C. What we are talking about, AC gives you the product. Okay, so which factors this thing? You see 4 times, of course, in most cases, these are this. In most, not all cases, they are most likely to give you the 2 factors. Anyway, you see this will be 3 and 4. When I add them, I get 7. When I multiply them, I get 12. So I have the pair already. You start the product is positive. It means that they have same signs. The moment you start the product is positive, same signs. The moment you start the product is negative, different signs. As simple as that. Look at this. Now this will be 3x squared. Attach x here, attach x here. Plus 3x plus 4x plus 4. What is common here? So now what is common is the 3x. You see that it has the 3, it has the 3. As x, it has x. So it means that 3x is common here. Here, you start what was common here, it was only y. But here, you have the 3, you have the 3, you have x, you have x. So, if I remove the 3x here I remain with the x. So I will multiply this and this, I go back to this. Now, if I move 3x here, get 3x divided here, will be having 1. Multiply this and this will go back there. What is common here is only 4. 4 into x plus 1. Then you see this and this are common. Then into 3x plus 4. And you are through with that. Just like that. When you go to the other one, you start the product. Our product is 2 times 5, which is going to give us a 10. Now this start is positive. Meaning, what does it mean? It means that now they are, remember this is positive, same signs. Now 10, I think you are seeing the values already. So it means that same signs when I multiply them, but because this sum is negative, it means that all of them should be negative. So I'm going to get negative 2, negative 5. So this will be 2y squared minus 2y minus 5y plus 5. Why are we doing this? To create even terms. When the terms are even, we can easily factorize. 1, 2, 3, 4. 4 is even. These were 1, 2, 3, which are odd, and it's hard to factorize. Now, when you simplify negative 2 minus 5, you go back to negative 7. So you have changed nothing, completely nothing. But you have made life easier. So 2y is common, so remove 2y here. Here remain with 1y. Here remain with, when you get this 2y divided here, you get negative 1. What is common here? You need a y which is positive, so remove this coefficient. So negative 5 is 2y. So this negative 5 when you divide it here, you get a negative 1. Negative 5, then it's negative 1, you go back to a positive 5. This is common, so 2y minus, okay. I had factorized that once. I don't know if you can see it, but maybe do it the way which is this and this are common. So y minus 1, then this, we'll remove it here. Okay, now I'm going to handle the last two. What is the product? The product here is going to be 9 times 3. 9 times negative 3. 9 times negative 3, which is giving us negative 27. Remember it said that a product which is negative, different signs. A product which is positive, same signs. Now here we have a negative. It means that the sum of, the results should be having different signs. Okay, what are they? They are themselves, they are already here. But you need that one of them should be are positive. Of course, if this is positive, the big one should be positive. So now I have minus 3y minus 3. When you factorize, when you simplify this, you go back to this. Even if you start with negative 3 here and you end here with 3, it will give you the same answer. Even if you start with 4 here and you end with 3 here, it will give you the same answer. So what you start with, and as long as you maintain the sign. So even if I start with negative 3 and I end with 9 here positive, it will give me the same answer. Okay, so 9y is common, y plus 1, then minus 3 into y plus 1, which will be plus 3, as simple as that. Okay, now when I come to this, the product is going to be 4 times 5, which is 20. The product is positive. If it's positive, what comes into your mind? Same signs. They can be negative, negative, or positive, positive. Okay, the product is 20. Instead, my product is 20. What are the factors? These are not the factors now. What should I get for 20? Now, it means that I have a negative. It means the big one is negative. So, this is going to be negative. Sorry. The product is 20. Okay, what do we have in 20? We have 1, we have 2, we have 4, we have 5, we have 10, then we have 20. So now, you start two numbers when they are product. Negative, negative. Sorry, let me simplify. Let me make this expression B. Let me make it B. Let me make it B like this. Hey, let me change this expression and I make this to be 7x. 7x? No, not 7x. Let me make it minus 12x so that we can get when these are not the products. Now I want when these are not the factors. Okay, so we have the product as 20. What factors do I need? When I add these ones, I can't get this. Even if I subtract them, I can't get it. So this is not the pair I'm going to use. You look at the factors of 20, which two when you add, you get negative 12, and when you multiply, you get 20. I think you see that the pair is going to be 2 and 10. Yeah, I want this because this one already it was dictating as if these are always the factors. No. Now in this expression, these are not going to be the factors. But the product is 20 and positive. The one is positive, same sign. So the pair I have is going to be now 2 and 10. But because the product is positive, all of them should be. You see, when they are positive, I'll be having positive term, but this is negative, so all of them should be negative. So that's how I get the pair. This will be now 4x squared minus 2x minus 10x plus 5. When you simplify this, you go back here. What is common here? You see 2 is in here. X is here. So 2x is what is common. When I factorize out 2x here, you get this, you divide it here. When you get this, you divide it here, you get 2x. Then remove 2x from here, you get this 2x, you divide it here, be having minus 1. Then what is common here? You see, I have 5 here and I have 5 here. What I do, now I want this to be, the coefficient of x, I want it to be positive. Meaning, I want to remove a negative 5 from here. When you divide a negative 5 here, you'll be having a positive 2x. When you find a negative 5 here, you get your negative 1. And the brackets are the same. So you have 2x minus 5 into 2x minus 1. And that's how we factorize that. So remember, that's how we handle factorization of quadratic expressions. I wish you will. Now, we are going to see what happens if you have m squared minus 4. How can you factorize this? The terms are even 1, 2, How do we factorize this? It's what we are going to see in the next lesson, where we use a difference of two squares. Boy.